tooling and how to use them, and that might be overwhelming for users and people new to that stuff. Bryn will talk about how that might be made easier for the community.
Thank you. Yeah, there's been a lot of attrition. It feels like doing the presentation in the morning is the right one to do, but there's the recordings, I suppose, as well. So you've heard a lot about a variety of tools today. I think there was Accudoctor.eos, there was the one by TNO, ESIM, there was Pipeser, there was Verigrid. There's a variety of tools that you've heard today, and maybe about 5 or 6 different tools. And they probably constitute on the order of about 200 open source energy system modeling tools. We're being really, really specific here. These are tools for infrastructure planning and operation, open source, that we know about. And it means that it's a real big problem to keep track of the tools that are available, unless you come to every single possible conference where people are talking about these things, and maybe you'll pick up 1 or 2 each time. Or you read review papers, because actually things often come from the academic literature or academic community. These things are often developed in academia. And so you could go back, you could read a review. Pretty much every single year there will be a review about the latest developments in open source or just general energy system modeling. Maybe even, I think in 2022, there was about 5 or 6 reviews that came out in the same journal that were all about what are the latest developments in energy system modeling and the tools available. And it's effectively a losing battle, because you read these, you might get the latest developments and the tools that they know are available. They might grab about 100 maximum of the 200 that are there. And they are also probably about 2 or 3 years old by the time you read this paper, right? So they've started their review as a PhD student probably. They've taken some time doing the review, go through the actual the academic review process, the peer review process, and then you read it a few years later. And inevitably, they get a lot of things wrong. So I've been a lead developer of one of these 200 tools for about 9 years. And I can tell you, every time I read one of these, they've always got something wrong about what my tool can do. Because they are reading it from an external perspective, and maybe that's a sign of me and my documentation, but it's true for a lot of the other tools as well that I know about. So this is where it comes in a project that we've been undertaking at the Open Energy Transition with support from Breakthrough Energy Grids Initiative to map all of these tools that are available in a fashion that will stay up to date continuously. So what you see here is a snapshot of the latest update. It's a monthly update we get. So this is the January update in terms of a snapshot of the top sort of 15 or so tools of these 210 that we've got in the inventory. I can show you, I hope, what that looks like in a bit more detail here. So this is it live, openmod-tracker.org. And we've got a couple of caveats at the start. I want to be very clear. We believe we're catching most of the open source tools that are out there. We probably aren't catching them all. And don't blame us for the data associated with your tool. Right? What I'll tell you in a minute is we get most of this data from elsewhere. So you've got the table here. Got a couple of different pieces of information that might be useful to you when you come and look at it. You've got the link to the source code. So all of these have to have openly available, publicly available source code. You can get a link to the documentation, and we have a link to all but 60 or so tools documentation. So this is a really good resource if you just want to find out how to use a tool. I think we do a better job than the readmes of most of the repositories of telling you where their documentation is. So check that out. And then a variety of metrics associated with the source code repositories for these tools. So things like when was it created? When was it most recently updated? How many stars does it have? This is ordered by stars at the moment. Number of contributors and the development distribution score, I believe was developed in Open Sustain Tech. And both of those really are sort of a bus factor. It's trying to tell you, if there's 1 or 2 developers and a really, really low DDS, it's telling you that if they go out of action, they choose to leave the industry, that entire project will probably die with them. So you want lots of contributors, you want a high DDS. You want a lot of forks, you want people interacting with it in lots of different ways. And you want to know how often it's downloaded. And that's a difficult one because we can only get that for verifiable downloads. Things that are indexed on package indexes, usually Python packages, is what that's possible for. And a couple of other data sets as well. You can do things like filtering. You can say, well, I only want to see ones that have documentation, maybe ones that are at least 5 or 6 years old. I want them to have a bit of pedigree. Maybe you want ones that have a certain number of stars associated with them. So you can do a variety of filtering actions to take you through and really filter down on the tools that might be of interest to you for whatever project you might be doing, whether that's as a user, potential user for a tool, or potential developer, somebody joining the development community for a tool. There's a lot of possibilities there. You can also deep dive into a few other things. So we've tried to capture all of the users of these tools across GitHub and GitLab, if they're on those ones, and try to classify them to get an impression of the types of users of these tools, the people who are interacting with these repositories. We don't do that great a job, right? So about 65% of the users on GitHub who interact with these tools, of the 15,000 or so that we're picking up, no, 16,000 now, we don't get about 65% of them. That's because it's just their GitHub username and no other information, and we can't hope to do any better than that. But of those who do interact, we get a lot of people from the academic community. There's a little small few. If you go to the actual thing, you can have a look at it in more detail. Academic community, research organizations, professionals, and industry, they're all interacting in various ways. We can look at which organizations they are. NREL now, the National Lab of the Rockies, I think, is a big one. We, Open Energy Transition, are also a big one. A variety of other ones. So you've got things like Chinese universities or US universities. You can look at this on a tool level, so that was for all tools. I'm just going to look at one of them here. Maybe Verigrid is in here. There we go, Verigrid. Sorry, this is really picking on you, but you come to mind. And we can see various organizations who've got involved, various countries where the users get involved. So you can see the international sort of community that might be involved with it. You can maybe look at another one alongside it. We had pipes afterwards, so we can add that in. We can see across those two tools sort of the global reach in terms of the kinds of users who are getting involved, at least the ones we know about, that 35%. And we can look at the project development metrics. So we can say, okay, for these projects, some information about their development cadence, right? How are they waxing? Are they waning in terms of their level of development? Pull requests, issues being opened. Who are the top contributors across these? This is the top contributors across all of the projects. Who are the top organizations? And in what way do they contribute? Do they contribute in terms of opening issues? Do they contribute in terms of reviewing or giving feedback? And what is the type of feedback we're getting? So time to close issues, time to merge pull requests, all useful information for understanding how well a project is running and how much engagement is happening during resolution. Is there good feedback on reviews? Can you trust the review process? Is there enough feedback on it from that perspective? So all of this is possible from this dashboard that we've created in order to help people understand the future of energy system modeling or where they might want to go. So what we do is we have to kind of herd cats to achieve this. We go to a variety of upstream inventories of these kinds of tools, and we grab them all in order to pull together all of the tools that we bring. So we know of these. If you know of more, really happy to know about them. We want to pull in as many as we can, then we do some triage kind of. We remove duplicates, we filter things out. Exclude some tools that we just know for sure. Repositories that we know for sure are not energy system modeling tools, but they've made their way through to these upstream inventories. And they also have to have open and public source code repositories and public licenses, like permissive or copyleft licenses usually. We tend to find that actually just getting stuff from academic reviews and building a manual data set does the best of all of them in terms of unique tools that you don't find anywhere else. And some inventories don't provide any new tools to the mix. So they have tools, but they're mentioned elsewhere as well, so they don't actually add any new information for us. We bring this together with the Ecosystems API, and I'm sure Andrew Nesbitt, I think it is probably somewhere at FOSDEM this weekend, and you should really find him if you can, because Ecosystems is a great API to make use of, and we get all of our metrics from there. You can also blame them when the information looks weird, because we're not doctoring that information. We take it and we just show it as is. We also do some scraping to try and find the docs pages in a bit more detail, because we don't get that well from elsewhere. That gives us some stats, and then we go directly to some direct APIs for GitHub and GitLab, and that gives us the information about our users and about the repository's interactions over time. This is all run in about an hour and 20 minutes in a GitHub CI. The time is mostly in this GitHub and GitLab API requests, but we run that just automatically. It's sort of set and forget now that it should happen monthly. I say that, but the last one failed and I had to fix some bugs, but in theory it should run set and forget. So instead of you having to wait for the next review next year on the tools that are available that comes out of academia, you can check this dashboard instead. So why might you use it? Like who's going to it? And we at the Open Energy Transition, we've got sort of a mission, a vision to make open source the norm in energy system planning by 2028. That means going to energy system operators, transmission system operators, and working with them to move them away from proprietary tools to using open source tools for their energy planning. And that's our entire goal. And that means helping them understand what are the open source tools that are available and which ones might be most appropriate to them for a given use case. And we do this by helping them with the tracker here to produce a long list of possible tools for them, and then we deep dive, or we let them deep dive if they want to, into more information about those tools. You can't hope to look at 200 tools, but you might be able to look at 10 or so, and that helps you create a short list. So with one client recently, back in August, we started some things. We just added some really broad brush things. There has to be documentation. You know, it has to be easy for them. If we hand over the tool to them, the model to them, they have to have documentation. They can't rely on us. They have to rely on the tool itself. It should have an index package. The maintainer should care enough about it being easy to download cross-platform. And usually that means having a downloadable index package and so some monthly download stats that we can grab. When you have to compile things and you are talking to somebody who's limited their like technical knowledge is usually Excel on Windows, you have to work with that, not against it. And things like permissive source code licenses so that if they internally have a tech team that wants to make some updates, they're not going to be limited by that. In this case, we also included copyleft. We have one column that is manually prepared because we've got some information on the top 30 or so tools about what kind of modeling can you do. So you can get some really high-level information about the kind of energy system modeling you can do, and you can use that for filtering as well. I should say, so PipeSo came up in the earlier conversation. They do rank the highest along a lot of things, production cost modeling. When I mentioned that I'm a lead dev of a tool for the last 9 years, it's not PipeSo. So it's always quite galling to talk to clients and be like, actually, you know, the tool that's looking best here for you is PipeSo. I kind of just have to say that with a straight face and let it lie. There are other tools that do quite well in this for this specific filtering for this specific client. And yes, okay, they do well across these, but can you choose what weighting to give them? Because some, you know, might matter a lot more to them than others, and that it's very difficult to put weighting to forks versus DDS, let's say. So we went in and we did a much more detailed analysis, and these are the kinds of things I'd love to automate in the dashboard. And if you've got ideas of how to do it, I'd love to find out. Test coverage. I'd like to find a way to automate accessing test coverage information because people publish their test coverage or store it in different ways depending on the language the thing's written in and other decisions. The quality of their documentation. I might go to a documentation, it's a single page, this is how you install it, good luck. So it looks like they've got documentation, but actually they don't, so that requires some manual stuff. Where can you get community support? Where can you get data? We've heard a lot about energy modeling tools and the fact that you need reference data. If you can get a tool but you don't get any data with it or any way to access the data or link it to that tool is functionally useless to a lot of energy system operators. So reference databases for tools, you know, other tools that can link into it really easily, seamlessly is really important. Etc., etc. So we can go through this process of shortlisting through this. And we did this with them to shortlist to about 3 or 4. And that was really good. And they found it really useful to have this sort of verifiable way to how do you shortlist tools so that they can then go back to their higher-ups and say, this is why we want to go open source, and this is how we're going to do it, and this is why we're choosing this tool. But we need to dig deeper. Because we just heard earlier about PipeSo and its stochastic optimization. If you'd asked about PipeSo and you wanted stochastic optimization 6 months ago, the answer would have been, it's not the tool for you. But you wouldn't know that from any of these metrics, right? So we need to dig deeper into this and look at other features. And we went with a proprietary tool feature set. I won't tell you which one because I don't want to get into legal ramifications of it. And looked at what are the features that proprietary energy system modeling tools have, themed them. Don't have to remember all this now. It's all available in the GitHub repository. Grouped them and then created a variety of features. So basically a feature taxonomy of energy system modeling tools, but one that isn't too technical. It needs to be really understandable to potential users who, as I said, aren't super technical. They know they want to achieve a certain task, but they wouldn't necessarily know the technical words for what that might be. That brought us on to a new dashboard, dashboards upon dashboards. You will probably tell if you go to any of these, I'm not a front-end developer. And actually, I've seen a lot of Streamlit apps today in this room, so I'm guessing that most of this room are not front-end developers. But it does the job, and these are all prototypes. They're not aiming to be production ready. And this is very similar. It's actually going to be an extension of the other page, in which it's its own page that you can go in. You've got your tools here, and then you've got specifically what are the features they've got grouped. And most importantly, and this is what you're not going to get that easily in any of these review papers, verifications of that feature existing. All of these little superscripts are a link to a page in their documentation or their source code, their tests, that prove that that particular feature exists, but also help you understand how you activate that feature in that tool if you want it. And whether something's in development rather than, so this one here, whether it's in development rather than actually ready. You can use it to also filter it based on the use case you've got. And I'm not going to go into this detail because clearly I won't have enough time to do so. But you could say, okay, I'm running an integrated resource plan, which is usually what is done in the US, but in particular to make high-level decisions on the future asset capacities that you want. And we've gone through and relatively, with some degree of subjectivity, we've gone through and said, what are the features needed by this? And this is a filter view of those features. And then you can look at your tools and say, okay, which ones meet those features the best? You can do that side by side specifically on use cases. So you could look at all of these and you could say, okay, look at it for Pipeser. How is Pipeser doing for all of these next to each other? So you look for a single tool, but you look across all the use cases. And finally, you could look and you could write your own use cases. So you could say, okay, here's all of the options. It gives you a little tool tip as to what we mean by it. Click all of the things you're interested in. Save it. I'll just click a couple more. Save it, and then you can go back. That's saved, I think. And then I can go back to the use case comparison, and I can look at it in that context. Or I can look at the tools comparison, and I can look at it in that context as well. So I can look at my custom use case and look at it in that context. So it's a way for you to be able to, and as I can see here, a UI issue here, I can't scroll down, so there's clearly a problem there. But it's a way for you to be able to discuss with others what are the features we need for our tool, and therefore what are the tools that are most appropriate. This is a manual task. Right, it requires the developers usually themselves to contribute to this. So that's why you only see 4 tools. I'm hoping to see tomorrow VeriGrid on here, right? Yeah. SM will be here shortly afterwards, and then I'm sure that GemsPy will be here soon too. The value of adding your tool to this is the fact that then it will be used in the decision-making process by energy system operators, because we will be showing them this dashboard, right? We won't be filtering it for Pipeser. We'll be showing it to them vanilla. So get it up there as quick as you can. This is a little bit what it looks like inside the feature set. So you've got just a simple YAML config. We took sort of some inspiration from Conda Forge as to feedstock maintainers. So you've got maintainers of these lists. They don't have to be the developers of the tool, but you've got maintainers of the list, and they will be always tagged if there's some need for them to do anything. We've got version schema for all of these, so you could have different features, feature lists that are tagged to different version schemas. This is where I said you've got these sort of sources to the specific use cases, and those will be checked in review. And then similarly for use cases, the only addition is that we've got a list of the assumptions that go into that subjective use case list. So where are we going? We want community engagement. That's why I'm here today. And we want to improve UI and UX. We'll probably get a front-end developer to actually look at this and hope they don't scream. We want to add new insights. We want to add things like what are the academic and ideally non-academic uses for these tools. We're going to rely quite a lot on ecosystems for that and OpenAlex. We want longer-term download stats. In the last 12 months, PyPy and Anaconda and Julia, there were 3 million downloads that weren't CI-related downloads of all of these 200 tools. So last year, 3 million downloads across all of those tools. That's not capturing all of them because we're only capturing really Python, so we're missing quite a lot. So we want to get more analysis on that, and we're going to rely on ecosystems as well for security analyses of dependencies, because energy system operators want to be certain about the security of these tools that they're using. We're going to be doing that a variety of ways over the next sort of 6 months or so. So really, if you want to get involved soon. Looking at UI improvements, we really want to refine this taxonomy, make sure it's useful to everyone, useful to developers, so that they understand what they're missing, and useful to users so they understand what they need and what they can get from the tools that they're using. Just as a sort of a case in point of how we use this, so this sort of feature gap analysis that we've got here, we've worked with the Pipesa team to look at all of these things that are missing, created a roadmap on GitHub with issues which, if all closed, will close this gap between Pipesa and probably the leading proprietary tool for energy system modeling. So you can go through this process. By doing this yourself, you can say, well, what am I missing relative to what proprietary tools can do, and create a roadmap for yourselves to be able to close that. Great, so that is me done. These are the two dashboards, but also the two GitHub repositories associated with them. And as I say, this was done with a lot of ultimately financial, but also inspiration support from Breakthrough Energy to achieve this project. Thank you very much. Two minutes, right, rapid fire. There will be tools that do low and medium voltage, yes, definitely. But these are generic tools, right? So for the most part, low and medium voltage is a data problem, not a tool problem, really. So it's more about how the modeling is done in terms of the tools. So yes, there are several that can do low and medium voltage. That was the question. Yes, I shall. Yep.
Yeah, do you know the EU open source solutions catalog, and could there be some integration that you make sure that your tool is findable and it ends up at the EU catalog?
So do I know the EU open source solution catalog, and could there be some synergies there? I do know of it. This is obviously global. It's not just EU specific in terms of its use cases. But yeah, we would want to link to it. We should probably actually think of it as an upstream inventory more than anything else, so that we could potentially get more things from it that are indexed on it, but not in the other ones we've got. At the moment, we're not thinking of then downstreaming what we've got to other places.
How did you filter out the CI-related downloads?
PyPy has that automatically in their BigQuery database. And that's the main one. Anaconda doesn't, but it's far fewer downloads than PyPy. And Julia does it automatically in terms of removing CI from downloads.
Would this also help to assess the return on investment of actually building open source?
Yeah, would this help return on investment building open source? Yeah, I mean, what I'm hoping it does is stop anyone from building a new open source energy system modeling tool. Because that is probably the worst return on investment. Yeah, it's already leveling up. We see that, but that might be just because of where we're getting the data from, that we're not capturing the latest, the newest ones. We are hoping that people will use this to support financially support tools, based on choosing tools that look like they're mature enough to be worth supporting, and that have strong organizations backing them in terms of working on them. So we're hoping that people will look at this also from a financial backing perspective as well. Not sure how they would work out return on investment. But yeah, the key takeaway is that don't start developing a new tool now. Cool. Thank you very much.